Lesson 10.4. We're going to be solving polynomial equations that are already in factored form. Okay, so what we have here is we have a problem where we have two binomials, and they're technically being multiplied by each other. And what we learned yesterday was that when we see a binomial like this, we use FOIL and we solve it, okay? We do it as simplified as far down as we can, but they're not asking us to simplify this. They're not asking us to multiply. What they're doing is they're asking us to solve for x. As you noticed yesterday, okay, these expressions that we were doing were not put equal to 0, but today they are. I have x minus 2 times x plus 3, and they both equal 0. So what I'm going to do is I need to solve each of these equations for 0. So the easiest way to do that is I can make this two separate problems. I know that x minus 2 is equal to 0, and I also know that x plus 3 is equal to 0. So at the end, I'm going to find that I do have two different answers for x, but you always should have two different answers for x, okay, when we're doing these type of problems anyways. All right, so this first problem, x minus 2 equals 0, what would I do to solve for x? Dexter? Add 2. Very good. Add 2 to both sides. This cancels out here. Add 2 here. X equals 2. I've got my first answer. I need to do the same thing to the next problem. What would I do to solve for x, Jack? Subtract 3 on both sides. Very good. Subtract 3. I get x equals negative 3. So I just solved these equations that are in factored form. Okay, let's do the next one. Now the next one I notice I don't have two binomials. I have x times x minus 2. Again, I still have two different terms though. Well, two different sets of terms. This is its own set and this is its own set. So what I want to do is, again, I want to set each of them equal to 0. So I'm going to write x equals 0. That one's already done for me. I don't even have to do anything. I'm going to go ahead and box it in. And then I also have x minus 2 is equal to 0. Again, I just need to solve this equation now. So I add 2 to both sides, and I get x is equal to 2. So now I have my two answers. Okay? Let's look at this next one. 5 times x plus 5 times x minus 9. Now, this one's a little bit different because we've already dealt when there's a variable on the outside, but what about when there's a number? Okay, let's set each of these equal to 0. This is its own term, so I'm going to write 5 equals 0. First of all, does 5 equal 0? No. So this just cancels out. It does not mean anything to me because there's no way to solve for a variable. I know that 5 does not equal 0, so it's like I don't even have to worry about it. So what I'm going to do is I'm just going to write x plus 5 equals 0, and I'm going to write x minus 9 equals 0. Solve each of these. I subtract 5 on both sides. X is equal to negative 5. And I add 9 on both sides. X is equal to 9. So those are my two answers. So basically, the difference between that second example and the third is a variable can be set equal to 0. However, a number cannot be set equal to 0. Unless that number is 0 equals 0, that's the only way it would be a solution, okay? But it is not. That number was 5. 5 does not equal 0, so I just get rid of it. All right, let's do these next two types of problems. We learned yesterday that this little exponent here does not mean, oh, I distribute it to both of those. Instead, what does it mean? I have two problems. I have x plus 5 and I have x plus 5 again. They both equal 0. All right, let's separate it out. X plus 5 equals 0. X plus 5 equals 0. All right. What should I do to solve here? Sarah? Subtract 5 on both sides. Cancel out. X is equal to negative 5 here. Let's do the same thing over here. I've got to solve for x, so I subtract 5 on both sides. I notice that x is equal to negative 5. Now, wait a second. I already found out that x was equal to negative 5. Is it important for me to write it twice? No, it's not, because it's the same thing. So really, in order to save yourself a shortcut, anytime you see a binomial squared, whenever you're solving, just solving, not using FOIL. Now, if you're using FOIL, you do need to write it out twice. But when you're solving for x, really all you need to do is just solve it one time, because I don't need to write it twice. I'm going to get the same answer every time, so it's just kind of pointless work that's wasting my time, okay? So let's do this next one. 2x minus 4. I notice that it's squared, so I don't need to do it twice, okay? I'm just going to write 2x minus 4 equals 0. What is my first step in solving this equation, Trent? Add 4 to both sides. Very good. Addition, subtraction always comes before multiplication and division. So I have 2x is equal to 4. Now what should I do? Sarah? Divide by 2. And I get x is equal to 2. Again, I don't have to write it twice because the second answer is going to be the exact same thing. And lastly, this time I have 3 binomials. Guess what? It's not going to change. The way that I solve these are the exact same. The only thing that's different is this time I've got to set 3 different equations equal to 0. So I'm going to write 2x plus 1 equals 0. 3x minus 2 equals 0. And x minus 1 equals 0. Now I'm going to solve these. I'm going to subtract 1 first. 2x minus 1. Then I need to divide by 2. And I get x is equal to negative 1/2. That's one of my answers. All right, let's add a 2. Add a 2. 3x is equal to 2. Then I need to divide by 3. Divide by 3. X is equal to 2/3. Second answer. And lastly, I just need to add 1 here, add 1, and x is equal to 1. So on this next one equation, I'm going to do the exact same thing. Set them all equal to 0. X minus 4 equals 0. X plus 6 equals 0. And 4x plus 3 equals 0. Again, it's okay if you get fractions. Doesn't mean you've done something wrong, okay? You solved the equation. It's okay to get a fraction as your answer. Add 4 here. Add 4. X equals 4. Subtract 6. Subtract 6. X equals negative 6. Subtract 3. 4x equals negative 3. Divide by 4. X is equal to negative 3/4. These are my final answers. That's exactly how you solve polynomials already in factored form.